So I'm going to talk about what makes code beautiful, not really in a definitive sense, but kind of in an exploratory sense. A high-level agenda we have is I'm going to look at definitions of beauty that people have made in the past. From all those definitions, synthesize a simple working definition of what beauty is. Take that definition, apply it to software to see, by using that criteria, how we can determine whether or not software is beautiful. Consider whether or not evaluating beauty relates to code quality at all, and how it relates. And then we're going to see if any of this is actually useful, right, or just a sort of academic experiment. And then from that, assuming that we think it's useful, how we can actually apply it to day-to-day work to our benefit. So the first question I have is to the audience. I'm interested what people think are beautiful to them. Anyone from the audience? Think about what's something that's beautiful to you. Okay, wife? Okay. What else? Kids? What else? Seriously? Expressiveness? Okay. Clem's paintings. Okay. Okay, so for stuff like your wife, this might be personal, but why is she beautiful? I'm serious. I'm interested in the answer.
She's yours. Symmetry?
You're speaking for his wife, or? Okay, who said flowers? Okay, so do you have a flower in mind? Okay, Chameleon, tell me about why it's beautiful. It welcomes spring? That's interesting. Okay. So, I'm going to look at historical definitions of beauty. And the first point that I'm going to bring up relates to the question and the answers that you all provided about why you think things are beautiful. The first important point is that usually when you ask somebody what is beautiful and why it's beautiful, they'll say something like, "My wife's face is beautiful," or looking at my children's face is beautiful. But the important point that I discover through reading about all these definitions of beauty is that there's something deeper than just appearances that actually dictates what makes something beautiful versus not beautiful. And it's sort of a subtle, but it's an important point to make that the actual properties that make something beautiful, according to some definitions, are these sort of deep structural things that the physical appearance of something only ends up revealing through its appearances. But it isn't the appearances itself that are beautiful. It's just the fact that they happen to manifest a whole bunch of properties that go into actually making something beautiful, right? And so it's discovering what those properties are and having a vocabulary for those properties that allows you to have a more concrete definition and notion of what is beautiful. So I'm going to go into just brief background about myself to talk about why I'm interested in this stuff and why I looked into it. Unlike a lot of the room, I wasn't doing awesome basic hacks when I was 5. I was like reading books. And I studied literature in college. and linguistics, and was interested in linguistic semantics and stuff like that, which is, of course, why I'm doing programming now, because there's no money in that. But stuff I was interested in was how sentences make meaning and how slight modifications in sentences radically change the meaning of things, how there's a whole bunch of information implicitly implied in meaning. Like, for example, if someone says to you, "Can you pass the salt?" They're not interested in your capability of passing the salt. They really mean, "Give me the salt," right? But all that stuff is transmitted and understood through the expression. Another example is an example I've used before, which is if you're reading a book and the book starts off with a sentence like, "On that day, out by the carousel, because he was tired, it hurt too much, and he didn't want to wait anymore, Michael ended his life." Okay? First sentence you read in a book. You compare that sentence with, "On that day, out by the carousel, because he was tired and it hurt too much and he didn't want to wait anymore, Michael peed in his pants." Radically different, right? But until you get to the end of the sentence, they're identical. And there's a suspension that there's a tension that's established until you finally resolve it by understanding what the intent of the sentence is to be conveyed. And that wouldn't happen if you said, "Michael killed himself on that day out by the carousel because he was too tired, it hurt too much, and didn't want to wait anymore." Right? So, in linguistic terms and in literary theory, there are different reasons for doing one versus the other. There are rhetorical reasons for causing the reader to create a buffer in their mind of uncertainty where they're accumulating facts and trying to synthesize them into what they mean, et cetera, et cetera. Anyway, words mean stuff. We all know that, right? But I was interested in those kinds of ways of making meaning and differentiating better and worse ways of making meaning and determining how some are better suited at expressing other things and eliciting certain feelings, etc. So, it turns out all this kind of stuff comes up a lot in software, albeit in a slightly different form. Because usually there aren't reasons in software to use rhetorical effects of withholding information before you actually convey what you actually mean. There's no real reason to do that unless you really want to piss off people who work on your code. But the same kind of topics, the same kind of way of thinking about how what you write makes meaning comes up when you're focusing on writing really expressive, good code. So I studied all that stuff, was interested in all that stuff, and it was a large reason why I got interested in writing software, and it appealed to me. But knowing that, I was realizing over the years as I was learning and gaining experience with writing software that I was really interested in achieving what I saw was beautiful code. And that ended up in a sort of mysterious way being the most important thing to me, that I cared the most about. And it was a large reason why, after evaluating all these different languages, when I arrived at Ruby, it rung the most true to me. It appealed to me the most. And it wasn't a fully conscious, I didn't fully rationalize and understand the reason why. It was just a response that I had. At the risk of getting really emo here, it's kind of important to mention these things. Because I had that response, but I didn't really know the specific reasons why I had that response. And then Rails came along, and people got excited in Ruby, and a lot of people started doing Ruby. And then a lot of people started talking about how elegant Ruby is and how beautiful code is and all this kind of stuff, and we all started talking about code beauty and all this kind of stuff, but no one really talked about what that means. In the same way that I can say, my wife's really beautiful, but if I say, why is she beautiful, you might not be able to really tell me why, because you just look at her and it's a feeling you get in your tummy, but your brain isn't going, her jawline is the golden ratio or whatever, you know? Nor should you. But I'm actually interested in, to the extent possible, taking what is kind of an ephemeral, ethereal quality, and to some extent trying to systematize it, because I identified that the driving motivation and the thing that made me want to write software was to make it beautiful. And so if I can better identify why and how that works, I feel like it'll allow me to better and faster achieve that end. So, if we do a brief history lesson on the way that people have seen beauty and defined beauty, one of the first people who starts talking about this stuff is Pythagoras. Pythagoras as in Pythagorean theorem. I assume everyone's done geometry. A squared, B squared equals C squared, right? He actually had a lot of stuff to say about beauty, and the anecdote that's the genesis of this is one day he was walking around town somewhere in the Mediterranean, and there was a blacksmith out working in the street, and the blacksmith was hammering on stuff. I don't know, horseshoes. I don't know if they had horses. But Pythagoras noticed that the sounds, the clanking of the hammer, had this appealing noise to it. He was drawn to it, and it piqued his curiosity. So he went over to the blacksmith, and he noticed that out on the table of the blacksmith where he was working, there was all these different hammers, and the hammers were of different sizes. And he was realizing that the sound that was made by the hitting of the hammer was different depending on the size of the hammer. And not only that, when he scrutinized it more closely, he saw that the actual relative different sizes between the hammers informed the different noises that were being made. So he started recognizing through more and more study that there was actual mathematical ratios between the size of the hammers, the pitches that they made, and he realized that that related to music, and it had the same qualities as the intervals between, I don't know anything about music theory, but it totally made sense in music based on the size of stuff, right? If you look at a guitar or whatever, the strings have a certain thickness, et cetera, et cetera. The point being there was like a deep mathematical logic to the relationship between the size of things and the sound that was created. And it turned out that those relationships were discovered, like he identified those in all kinds of places in nature and in things that were constructed. And it ended up being the basis for all kinds of stuff, like the ratio between columns in the temples that they built. And so it was the foundation of their architecture. And in the zeal of these discoveries, Pythagoras basically created a whole religion around numbers and recognized that the world was basically just built on numbers and everything was ordered in the world because it was all based on these mathematical laws. So this is just one kind of sliver of the genesis of the definitions that end up arising around beauty. But the point to bring up here is that beyond appearances, there are these deeper things that are beautiful or are not beautiful. And in his case, the sound of the hammers, the different size of hammers, were beautiful to him because they weren't 3 inches and 7 inches, they were 2 and 9, for example. And if they hadn't been those sizes, they wouldn't have been beautiful. So there are certain relationships, like mathematical relationships between the sizes of things that are beautiful in one case and are not beautiful in another. And that's more than just, that hammer looks cool, man, you know. So, there is a definition of beauty that arises, it's 1,500 years later, by Thomas Aquinas, which, of all the definitions of beauty I found, seemed the most useful to apply to software. So we're going to look at that one in some depth. And I should mention, all these ideas of beauty that I'm going to be presenting are all Western. They're all hundreds of years old. And they're all very surface level explanations. This is not a rigorous academic PhD talk about beauty, and it doesn't make any consideration for any Eastern thought, and there's no consideration for contemporary thought. And if there were consideration for contemporary thought, and the people were here who were contemporary thinkers, would totally not take me seriously because things are way more complicated and undeterminable. And really what's beautiful now is the ugly and all that kind of shit. Anyway, so I studied all that kind of stuff in college, and I'm aware of the fact that to some people I'm totally wrong. That's not important. What's important is not to give you an awesome, rigorous academic talk. It's totally a pop talk. But what's important is to try to give you something useful as software developers that isn't a lie, that rings true and rang true and was useful maybe hundreds of years ago. But I still think I find in the work that I do, it is actually valuable to me, right? And it's effective, and I think it's true, even though it isn't deep and rigorous, right? So that's just a preface. It's not really an apology. I'm just mentioning the fact that there's so much more literature about this topic and a lot of contemporary thought about it that's very complicated and academic, but that's not going to be talked about in a 45-minute talk. So, Thomas Aquinas, definition of beauty. 3 things that define beauty is what he presents. The first topic that he brings up is proportion, and that's something we touched on with Pythagoras, the relationship between the hammers. So, a useful way to explain the notion of proportion and to think about it is to consider the design of my body. Specifically, we won't go, like I said, we're not going in depth. But specifically my hand and my arms. So if we think about the purpose of my hand, the purpose of my hand is to write code, grasp things, pick up things, point to things, drive, maybe play the piano, etc. So touch things, etc. So we notice I have a certain number of fingers. They're both mostly the same size. They're all basically equally spaced. They happen to be the same size as my palm, so the relationship between the fingers are equidistant. The relationship between all the fingers in the hand are about the same. And then the size of the wrist versus the hand, the length of the forearm and the length of this part of the arm, etc., across my entire body, right? So if my fingers were twice as big or half as big, they would not be as well suited for doing what they need to do, which is to grab things, etc. So for the purpose that it's intended to have, it's quite good. It's just about right. And if you modified it in any number of ways, it would become far worse at what it's intended to do. There are 2 concepts embedded into the notion of proportion. One is ratio of parts, which is what I was just sort of describing. The size of one part and the size of another part and the relationship between the 2 of them. The other is the economy of size, right? So for what my hand needs to do, as small as basically the simplest thing that works, but in terms of size, the smallest thing that works. So you want to have maximum economy in the object that is intended to achieve something. My hand would likely work if it was 10 times bigger with the same ratios, but there's a lot more overhead to being 10 times bigger, right? So if each of the fingers had the same relative size to one another, and the forearm and etc., but I was way bigger, it wouldn't be as good as if it was this size and achieve just as much the same, right? So 2 concepts here, both economy of size and ratio of parts. Keep that in mind. That's the proportion piece. The next piece is integrity. The metaphor for integrity is a crystal hammer, crystal or glass or what have you. The surface sheen of glass and crystal might be beautiful, but if you use that material to make a hammer, it's a terrible hammer because it's going to totally shatter as soon as you try to actually use it, right? So integrity is about having the thing be actually well suited for the purpose that it's intended for. Most supermodels are really beautiful, but without sufficient training, they're terrible neurosurgeons, right? So that's the second notion of beauty, integrity. How well suited something is for its purpose. The third is clarity. And clarity is a simple concept. It's something is clear and something is simple. For Aquinas, clarity actually had religious implications because claritas had to do with the brilliance of God, etc. Thomas Aquinas was a believer. But clarity for our purposes is easily applied to the notion of something being very clear and very simple. And if something is not clear and not simple, it can't be beautiful. Overly, complicated in the pejorative sense, there's a distinction to be made between sophistication and complication. Not the same thing, right? So if something is complicated, really big, and really bad at what's intended to do, it's totally not beautiful. So that's a simple working definition for what makes something beautiful, those three parts. Now we're going to apply that to a piece of software to see how this can actually relate to code that we write and consider how that might be useful. So I have a little case study of some code that I wrote. This is code that this code consumes XML documents from a web service, and it takes this huge piece of XML and it translates it into a Ruby object graph. So every single attribute inside of this XML document is delivered to you as a string. But a lot of those attributes really represent richer types that in Ruby should become the appropriate object. So you have Boolean stuff, you have dates, you have numbers, etc. So when you're parsing in all this XML, I needed to convert them to the appropriate rich object in Ruby. Basically simple conversion. So I was doing a lot of Haskell at the time. So I was thinking about things a little differently. And I was trying to think about what a nice API would be to doing this, to be able to add new types of coercions as needed, and do these coercions. So I came up with this idea of a coercible string. So we're going to scrutinize this a little bit. There's this top-level coerce method that's the public API to doing these coercions. And then under the sheets, there's a method called coercions, which presents all the different coercions that are attempted. And then there's the try thing, which actually manages each coercion. So basically, this uses the generator library, which encapsulates an iterator as an object. And each one of those try blocks represents a different type of attempted conversion. So the way that it basically works is it establishes this object that has all the coercions, and it says, try the first coercion. If that worked, we're done. Otherwise, while there's still more coercions, continue trying to coerce. And when it actually goes to trying it, it takes the string and does whatever calculation it does to determine whether or not it can be coerced. And the result of the expression is overloaded. The result of that attempt is overloaded because it's both, if it returns something that's Boolean true, it communicates that the coercion worked, but it also returns the value that you wanted to coerce it to. That works in every single case except for the second case, which is why there's an array, because the result of self equals false is Boolean true, but I in fact wanted to return false. Which is why I also, inside of the coerce method, need to do attempt.nil, the nil predicate, and I can't just do attempt or self, because I need to make a distinction between nil and false. So And then the try thing ends up managing the generator by either yielding the desired result or yielding nil if it didn't work out. So every single attribute inside of this XML document becomes I think there's a class method coerce that just wraps new and then calls coerce. But I would take every single attribute of this XML document, make it a coercible string, and then coerce it. And it would either just be the string itself or one of the successful coercions. So, an evaluation, if you will, as our friend Lizardus would say. How beautiful is this coercible string? So let's take a look at it. Proportionality. Proportionality, if we remember again, there's two parts of it. There are the relative size of parts. In this case, I think this is just about right. You know, there is all the methods are about the same size, and but that's not so pertinent here. The important point is the second part of proportionality, which is the economy part. What we're trying to do here is coerce, in this case, try 4 different coercions of a string. And so is this about the appropriate amount of code that's necessary to take 4 things, to attempt 4 coercions? Well, it turns out this is what I refactored it to. And this is half the number of lines, right? So in terms of proportionality, it's pretty bad because it can be done in half the number of lines of code. And in this case, we're trying 4 conversions, and this implementation is basically like 6 lines. So it's almost 1 line per coercion, which makes a lot better sense than 20 lines to do the same thing. So it fails on proportionality. What about integrity? Integrity is how well something is suited for the purpose it's intended to do, whether or not it can even do it at all. Here I'm using the generator library. In Ruby 1.9, the generator library uses threads. But in 1.8, it uses continuations. It's pretty slow. Not only is it slow, but I got an email a week after releasing this, and there was like a huge memory leak. I don't know why, but it had something to do with this implementation. So when I changed it to the case statement, my unit tests, which were only managing small XML payloads, ran an order of magnitude faster. Order of magnitude. And you should keep in mind that in the real world, this is handling huge XML documents, right? So it totally falls on its face and is terrible at dealing with a very large amount of data when it can't even handle a small amount of data. Totally fails the integrity thing. The case statement, on the other hand, fast. It's totally good at that. It's fine. Oh no, we failed integrity too. Clarity. Yeah. So I had to explain this. I had to explain this whole thing to you. And I did that without you asking. I didn't say, hey guys, do I have to explain this to you or do you get it? But I went ahead and explained it to you because I know it's not clear. Because I wrote it, and when I was trying to make my test pass, it took me a long-ass time. Because I didn't understand what was going on. Whereas this, you can't really get clearer than this. Well, I mean, of course you can't. Because we would give up writing software if you couldn't. But this is way clearer. So I don't know how you guys felt when you first saw this code. Some of you might have immediately gone, wow, that is donkeys, terrible. But some of you might have gone, oh, that's kind of interesting. I don't know what's going on. That seems kind of cool. So this is one of those things that when I wrote it, I didn't really know how good it was, but I was trying something, and at first it felt innovative. It felt cool. It was like, I had never thought about doing coercions this way. This seems like an interesting way of coercing stuff. And it turned out to be terrible. So, here's another important point to make about these three principles, is that they're not, you don't pick and choose one or two. They're intended to all work in concert, and they balance each other out. So they're each necessary, but none of them are sufficient. And you have to keep that in mind and always satisfy all three of them, because that's the working definition that we're going off of for beauty. So, for example, you can have proportion in terms of economy. Like you can have a very dense piece of code that accomplishes a lot in very few characters, and that will satisfy proportionality, but it'll totally fail at clarity. Who wants to tell me what's going on in that first line? I don't want you to. So, we have to keep in mind that all four need to be satisfied and that they all balance one another out. So, that's all fine and good, but why does beauty matter? I always like, as someone who studied literature, I don't have anything against engineering, but I kind of, for a while, I don't really feel it anymore, but for a while I felt like an imposter, and I felt like someone that engineers wouldn't respect because I don't read fiction anymore because I'm only reading like this, for example. And but when I did, like I spent all this time reading stuff that is intended to elicit like feelings, it's all very kind of emo, like how do I feel? That's what literature majors do. They sit in a room and talk about how this book makes them feel. Not really. It's actually cooler than that. But, so I have this paranoia and this anxiety about presenting ideas of beauty to people who are really interested in optimizing compilers. They don't really care about beauty. They care about engineering. But I want to present the idea, which is not my idea, but present the idea that I think for people who might think that kind of stuff is hooey and not useful, that in fact, great software and beauty go hand in hand and they're kind of synonymous. Assuming you're working off of real definitions of beauty and not misconceptions of what beauty is. So, for example, let's take as an example Kent Beck's small talk best practices pattern. So the book is called Best Practices, and what this book is Kent Beck working with small talk for, most of the 80s, and trying things and finding better and worse ways of writing software. And after a while, he came to realize this is a good thing to do, this is another good thing to do, et cetera, and eventually he synthesized all that, and he's like, I can write a book now and tell people what I find to be the best way to write good software. And this book is full of all kinds of lessons on how to design software better, right? I don't know if he uses the word beauty anywhere in the entire book, but if you look at the information he gives you and you think about the three principles of beauty, almost every piece of information in that book is driving you towards fulfilling one or more of the three principles that go to our working definition of beauty. So he's setting out to write a book about how to write great software. And it turns out that all the software that you create following those principles is also, by this definition of beauty, beautiful software. So it turns out that good software and beautiful software, if you believe Kent Beck, are the same thing. Even though he didn't say, I'm going to go do research on beauty and see how that relates to the way that I write software and prove that beauty makes software good. That doesn't mean he doesn't think about beauty and he doesn't know the word beauty and doesn't try to write beautiful software. But my point is, without thinking about beauty necessarily, or at least not telling the world that he was, he arrived at a definition of beauty just by writing good software and getting the feedback that he did from writing that good software. So just like Ken Beck, Rousseau found a similar relationship where for Rousseau, goodness, and good is a very vague word that can mean a lot of things, but good and beautiful are the same thing. Good is beauty in action, right? So how is any of this useful? Let's look at this case statement again. I don't think anyone in this room, well, I don't think most of the people in this room would look at this case statement and go, that's beautiful. This is just meat and potatoes programming. It's clear and it's small and it does what it needs to do, but it doesn't wow you with this aesthetic. You don't have an aesthetic moment when you look at this case statement. But like 40 years ago, when switch, or I guess switch is when the construct that was introduced into programming, 40 years ago that must have been amazing. Imagine having to work in assembler and then get a construct like switch, which is so much closer to the way you think about the world. That's like a huge innovation. And at the time was probably beautiful to write that and to experience that versus writing assembler or whatever else you were doing. In the same way that 300 years ago, Rubenesque women who now would be considered morbidly obese were the ideal of beauty, right? So there's a relativity there to what makes something beautiful. And right now, Ruby is the most beautiful way to write software. In 20 years, it might look like assembler, right? So it's a moving target, but even though the case statement isn't beautiful now, I think it probably really was a while ago. I'm pretty sure that John McCarthy, this is the guy who he didn't write Lisp, he just specified Lisp, but he's the father of Lisp. I'm also pretty sure that he introduced if into programming. Can you imagine programming without if? But people used to. So if might have been this really beautiful thing when it came out. Here's an interesting quote from Niels Bohr, physicist, Nobel Prize. By his definition, an expert is someone who's made every possible mistake you can make in some narrow field. I think that's a really interesting and really useful way of thinking about what makes someone an expert and how you improve and become better. A lot of times I'll be working on a really hard problem. It'll be really frustrating, and it's kind of unpleasant, which is not how you want your day-to-day work to be. But then I'll take a break. I'll go to the bathroom. I'll be going to the bathroom, and I'll totally figure out the answer. I'll go and I'll implement it, and it'll work. And then, at the end of the day, I feel like I've gone up one level and have reached this new plateau of experience. And it was because I had made all these mistakes, and then I finally resolved it because I figured out what was wrong, and now I know that that's wrong, right? So you accumulate all those mistakes together, and you end up gaining more and more expertise. So 40 years ago, whoever came up with the switch statement probably could have done whatever conventional way there was to express that kind of thing, in the same way that when I went to go try to do my coercion thing, I did this crazy-ass thing that ended up being terrible, but I was trying to do something different. I was trying to think about it in a way that might have been better. And after I evaluated it according to the criteria of beauty, it turned out that it sucked. But if I'd evaluated it according to the criteria of beauty and it hadn't sucked, it might have been a better way of writing software. So, lucky for us, Ruby is optimized for beauty. Big time. So we have this really fertile ground to build a garden in. So what I would propose, and what I'd like to propose with the simple definition of beauty, is when you're working on software, try to imagine better modes of expression. And just give it a try. A sort of prototype, if you will. And once you've given it a try, determine whether or not it violates those three simple rules of beauty. And it has to violate none of them to be acceptable. But if it violates them, throw it out or try something different or tweak it a little bit. But I think if you do that enough, you eventually might end up coming up with something really innovative that is beautiful and drives things forward. And I think this is a simple approach that I've used that I found really successful. And the fact that it's so simple is a nice little positive feedback loop to me, because the three principles in the definition of beauty themselves satisfy themselves. If that makes sense. So that's the end of my talk. I would like to finish just by thanking Mats and the Ruby core team for writing what I think is the most beautiful language I've ever used. So I'd like to thank Mats and give him an applause. I don't know how much time we have for questions, but I would like to do questions if we have time. Okay, a question or two. Anyone? Back there, and Stu. But you first. Yeah.
Okay, so the human body has DNA, and that DNA expresses reality. The code has source code, and then working implementation. Do both? They're all four. Do they all four have to be beautiful, or is it only the end result?
You said that human DNA expresses. Please reiterate. I have no idea what you're talking about.
Human DNA brings it out. How we look and how we act.
Okay.
And I was going to make that metaphor to software. And so, do we need to be focusing on the source code of software, or do we need to be focusing on the user experience, or both?
Okay, right. So what are we applying this principle of beauty to? Are we applying it to the code itself? Are we applying it to the experience that the user has? I think you can apply this definition to everything and at all levels of granularity. So one line of code, a whole class, for example, an entire library, a whole community, an entire project, etc. The user experience, of course. I think striving for beauty in everything you do and applying it to everything, it totally works. Yeah. Stu?
Can you bring the slide up with the beautiful version of the code?
Well, I didn't think it was beautiful, but.
Or the more beautiful?
No, this is actually the one that doesn't violate the rules of beauty. But in 2007, it isn't actually beautiful. But go ahead.
I actually think it is. I love what you're doing, and I think this is much more beautiful than the other code. And I wanted to ask you if it bothers you in this code that you've got strings and regular expressions for 3, but sort of an external constant for the 4th. Does that violate symmetry in your mind?
Right. So the way that this used to work, I don't know if everyone could hear the question, but he was saying that by the way, I'm not going to. I should also mention that you use the word symmetry, and that's something that I didn't actually mention, but is kind of implicitly part of all this. And there's interesting definitions of symmetry that I read. Put that on the back burner because I don't think we have time for that. But I think the summary of his point was, does it bother me in this implementation that I have 2 strings and a regular expression, then I have this external constant to define the date format?
format is just a constant.
I think a more kind of symmetrical way of doing this potentially is to do, for example, when, this would be kind of weird, but when date.parse rescue nil DateParse, even though you're executing that twice. But the reason why I actually have a specific date format constant, which actually maps to a regular expression, is because in this particular case, there was a very specific date format, and the implementation of date.parse is unfortunately very, I'll give you an example of why I have a regular expression. Well, I'll tell you why. If I do time.parse, quote, Marcel Molina, it returns a date. So it's better just to have a regular expression. No more time for questions? Okay, well, thank you very much, and thank you to the organizers.